Hello, welcome to this video where I show you how I build my Neo4J graph database and Cypher queries. So first of all, we have the JSON file and we need to clean the JSON file. So the issue with the JSON file was that there were some first of all there were some comment lines. Those we need to clean up, and also in this ID there was an extra like object ID, this kind of line, and we cannot have that for a valid JSON. So we need to clear those out. So first, what I did was print up the Jupyter notebook, and um, first of all, I stripped all the lines that starts with this comment stuff, so those are removed, and then I matched two patterns. These are the only two patterns I found where the JSON standard was breaking. So took those in, and I basically replaced them with whatever was inside. So that's what I do here: replace them, replace this, replace that, and I call those functions here, and then luckily there was another thing that after each document there needs to be a comma, and luckily there was like only after every document there is a blank line, so I can just find out the blank line and add a comma. So that's what I did here. I basically found a line where there is a line just like that. I just add the comma and then blank line. So once I do that, I have a cleaned file, and the cleaned file looks like this. And I also add this this needs to be there, bracket. I add this at the front and at the end manually. So now my JSON file is ready for import, and I start the Neo4J desktop installing that. I also did some stuff like in the import file, put the JSON file here, and also in the config file there needs to be this file that is I created and added a property to another import. Once that is done, I can basically open up my database after creating it, and once I open up my database, I start running these queries. Let me just show you. So, so this is for the part 1 of the assignment, and here we can see that first of all there are some things to clarify. In the data file, I want to take the tweets, but not only each of these document is a tweet, of course, but also for the cases where it is not a post but a share, like let me do this. And so in a share post, what happens is that there's actually a whole Twitter object. The original object is also here with an ID. So the share tweet has its own ID, and it has object attribute which has a whole Twitter tweet. So what I want to do is first I just take these tweets into the database, and that is through here. The only thing that is different here is that value.object.id, and everything is like object.health, that's like that. So this way I can take all of those nested tweets. Once I am done with that, now I want to take only the post, only the documents that are posts, and I do that here. So this is like as given as in the as a help from the question. So this is basically that code. I think I added only the verb argument property here, but from there. So now I have all the posts, all the tweets that are just posts, and now I want to also take in the share post. So simply I take in this similar to that, I just check if the verb is shared, and I think I could have not do this, just do these things in one query, but I did it twice. Anyway, all the tweets are now inside, and the share tweets are also their own tweets. And now what I do is there's an interesting thing here going on, that is in the file. So in the file, we know that in the verb share, we have a ID and we have a object.id, and these two are different because the object.id is the original object. But if it is a post, let's hope this is not inside something else. Like this. Let's go to the top. Okay, so this is a post, and even this has object too here, but this ID is the same as this ID. So we can easily see that for the post, the ID and the object.id are the same, but if it is a share post, then the ID and the object.id are different. Based on that, we can uh, do this. We can take value.id and object.id, and then we just check for inequality. If the inequality is true, if they don't match, then I create the relation between these two as retweet. Moving on from that, we have we are now going with the link. So we take the link and ID and we create. This is basically the same as the code that was given. I think I added the expanded URL somewhere. I don't know if I actually used this part of the code. Anyway, I think I added yeah, I added the extended URL. I think this was not used. Uh, so here what we do is we simply, the difference between this and this is that we take the Twitter entity.url. Always the Twitter entity.url only has either one object or zero object. If it is zero object, it's going to be null anyway. So we just take the first object and take it as extended URL, and we add that property on create set, and we also create the contains relation here. So now, so as with the previous case, since there is nested tweets inside the share post, those tweets also have link. So we also add them here. Object.id and object.everything is object.link, and we add them here. And now what we do is we want to add the source. So I take the source from the generator, the display name, and that is my source. I match the ID, and then I simply create the source node and using relation. And the same, once again, I take the nested tweets as well from those and do the same step and create the source with merge. And so if there is anything already existing, then they're not created. Then moving on, we have hashtags. So the hashtags are actually the list. So we need to unwind the list. And when we do that, this is like a for loop. So for each and every element in the list, we do this. We create a node which has text and the text from the hashtag, and we create this relation between the tweet and the hashtag. And once again, we use the object to do the same for all the objects inside the shared post. And now we have the we are going to take in the user. So first we take in these users as usual, ID with the actor.id, and the preferred username, I take that as my username, and I create with merge, and I could create with create here as well, but I did merge, and then created the relation. Moving on, I do once again the same thing for all those nested objects that also have a actor inside them. So I take those actors in. Now, so user mentions, I do basically the same thing for the user mentions. The user mentions are also, I think, yeah, so they're also lists. So I unwin them, and I take the ID string and string name. I do the same for the nested tweets, and in the end, I add two constraints that tweet.id has to be unique and the user.id has to be unique. That creates the initial database. I think maybe the bloom will show. In the meantime, let's go here and take some time to do it. This now we start with our in the part 2 queries. So this is the first query. I think I have a screenshot of this in here. So for the first query, we do this. We take the I think what was the query? Yeah. So we take the source using tweet and post, and we collect the distinct user because we don't want to have like a same user doing the things multiple times, and we count the number of posts, and then we simply return our display name number of name of source, the number of posts, that is the count, and the size, which will give us that this is a list collect user, so this is a list of users and we only take the size of that. Moving on, The second query, I think I did. Okay. Uh, I think I did this partially. So the question was uh, to find this. I did this too, but not the last part. Mm, I match the Twitter with the post of the user, the tweet, and then I simply take the count, and order them in the in order, and limit them to 3 and show them. That is my second query. And then we have the third query. So for the third query, this is actually the graph, the shortest path between that particular user and I think something else hashtag. So this is the path of that, the graph, and so the path length is actually 24, and this is the code. So what we do is there's a shortest path function given by Neo4J, and we simply take the user, and then we say that the mention post contains text and retweet. And I have to experiment a bit with this number because this is like how many is the limit. So once I set it to 50, I got finally the path that there is a path at 24 length, and basically this goes to hashtag, and I return the path here. And if I only return the path here, I can get a query graph. That is my I think part 2. So do this. Okay, part 1. This is the state after importing all the data. And moving on, I have part 3, and I guess part 3. Okay, so part 3. So here we basically what we do here is that we create two relation, one between the user and the link basically, and one between the source and the link. We do this because now we can check for activity regarding the link with which source is being used or which user is doing it without actually moving through the tweet hop and going through that. And there was another thing that we could do here is that we could index the link node on the expanded URL, but I figured that since it is a URL and most of the checks will probably use regular expression, and regular expression do not use actually index. So this is kind of a redundant. That's why I did not implement indexing here. And as for the question 3, so this is basically what I did. I used regex to find matches where there is either linking or the uh, this other LinkedIn in the expanded URL. If they are a match, then I do the remaining stuff with collecting all the users and their counts, and I take the max of the count that I counted here. And then for each of these users, I check the count. If it is equal to max, then I can return a collect on the usernames and the max count, which is basically the same as the user count. So once I do that, I get let me check. Once I do that, I get this result. And I think I have a part 4 here. So for this case, um, I think what we can do here is that we can add a new node organization, and because all the links are basically part of some sort of domain, and domains always have an owner or an organization, so we are basically denoting them here as organization, and we are making a relation between tweet and organization as refers. And then for moving even after that, we can also for checking with industry, we can actually add a node called industry, and we create a relation from organization to industry as relates, and this relates will have a property that is the type. So this type will be what type of industry it is. So that's how we can connect, we can analyze the links, and the organization will have a property domains under which all the domains that it has will be in this property. And yeah, I think that's about it. I don't think I'm much to show else. Um, maybe this. So this is how the graph shows. Thank you for watching.